This section is about rational equations and formulas. So all the work we did in the previous section was simplifying rational expressions, meaning something that doesn't have an equal sign. They were just fractions inside of fractions, or even, sums and differences inside of fractions. Here we're going to start solving them so that we get actual answers. Something like I put up there x equals 4, or w equals -6. One of the things that's going to happen when we solve these is we're going to have to go back and check our work to make sure that it's correct, because there are times that you get an answer that doesn't work. And so an answer that doesn't work is what we call an extraneous solution. The first type of these problems we're going to solve are cross-multiplying problems. These you very well might be familiar with. So sometimes these show up as proportion problems because these are proportions, right? You're saying two fractions are equal to each other. Saying two fractions are equal to each other is a proportion. So 4 over 7 equals x over 14. You might be able to look at this and go, well, 7 times 2 is 14. 4 times 2 is 8. Okay. You could also cross multiply. So we multiply the 7 times x. Right? So we multiply across this way, 7 times x. Then the other way, we multiply 4 times 14, which is 56. So divide both sides by 7. 56 divided by 7 is 8. All right, look at the one underneath it. 2 over 9 equals x over 15. Well, now this is a little harder to do in our head. So we cross multiply. We say 9 times x equals 15 times 2 is 30. And we divide both sides by 9. Well, 30 over 9 will simplify a little bit, right? We could take a 3 at the top and bottom. 30 divided by 3 is 10. 9 divided by 3 is 3. There's my answer. Is it okay for the answer to be a fraction? Sure it is. If you're building something or you're cutting lumber to match a certain proportion, it is possible that you could cut 3 1/3 feet of lumber board. That's certainly correct. How about the last one? 2 over x equals x over 18. When we cross multiply the x times x, we get x squared. And then we multiply 2 times 18, we get 36. Remember when you take the square root of something, if it's an x squared equals something, then we put a plus minus in front of the answer. So we get x equals both 6 and -6. So rather than writing two separate answers, I'll put a plus minus in front of my 6 to indicate that it could be 6 or it could be -6. The question is, do both of those work? Are both the 6 and the -6 valid solutions? Let's try them out. Suppose I started with x equals 6. I get 2 over 6 equals 6 over 18. Well, sure. 2 over 6 is a third. 6 over 18 is a third, so x equals 6 works fine. How about x equals -6? I get 2 over -6 equals -6 over 18. And sure enough, both of those equal -1/3. Right? 2 over -6 is -1/3. -6 over 18 is -1/3. So both of those solutions work. 6 and -6. There's actually a name for this. We call that 6 and -6 the geometric mean between 2 and 18. Not that we got to remember this for the next test, but those are cases where those numbers that we get have meaning as things besides just an answer to an algebra problem that's on this video. All right, take a look at this one over here. We got a 3y plus 6 over 5 and a 1 plus 3/4 y on the other side. So I'm going to try to get rid of my denominators. My denominators are a 5 and a 4, essentially. 5 times 4 is 20, so least common multiple is 20. Let's multiply left side and right side by the same thing. That'll get rid of our denominator. So I'm going to multiply this side by 20. And I'm going to multiply this side by 20. So I've got two sides of an equation. I'm going to multiply both sides by the same thing to get rid of all the denominators. 20 divided by 5 is 4. So that gives me 4 times 3y plus 6. Remember that 4 is still on the outside of the parentheses. It still has to be distributed eventually. On the other side, 20 times 1 is 20. Over here, 20 divided by 4 is 5. Now multiply that 5 times 3. And we get 15y. So we've gotten rid of our denominators. Right? The key thing, too, is don't forget to multiply that 1. 4 times 3 is 12, so I get 12y plus 24 equals 20 plus 15y. And now we're back to just a regular old linear equation. Right, maybe let's move the 20 over to this side. If we do that, we're going to have to move the 12y over to the other side. Can I do two things at once? I can. If you're uncomfortable, do it in two different steps. 12y's go away. 24 minus 20 is 4. On the other side, the 20's go away. I get a 3y. Divide both sides by 3. And I get y is 4/3. All right, this one's relatively easy to substitute back into my original equation to see if it's correct. Because over here, 3 times 4/3 is just 4. All right, so I get 4 plus 6, which is 10. 10 divided by 5 is 2. On the other side, 3/4 times 4/3 is just 1. 1 plus 1 is 2. So it works. All right, let's try some more. We're just going to look at a number of different cases and see what we get. Over here, I've got problems that have a's in them. All right, so on the left side of the equal sign, my denominators are an a and a 4. On the other side, they're just an a. So I got two options. I could combine the left-hand side into one fraction and then cross multiply, or I can multiply by something that gets rid of my fractions. All right? Let's say I want to get rid of my fractions. So I'm going to multiply everything on both sides by a 4a. So I'm going to multiply this by a 4a, multiply this by a 4a, and that by a 4a. When I do it in the first piece, the a's go away. 4 times 5 is 20 minus 4a. Right over here, the 4's go away. And I'm left with a 3a. And on the other side, the a's go away, and I get a 28. So I get 20 minus a equals 28. Subtract a 20 from both sides. Negative a is 8, so divide both sides by negative 1, and you get a is negative 8. All right, suppose I want to try it the other way. Suppose I wanted to create a common denominator on the left-hand side. I had a 5 minus a over a plus 3/4. Let's multiply this one top and bottom by 4 and multiply this one top and bottom by a, and now I got a common denominator of 4a. What do I have on the numerator? 4 times 5 is 20. 20 minus 4a plus 3a is 20 minus a over 4a. And now we can set up a cross multiply situation. So the left-hand side as a single denominator is 20 minus a over 4a. The other side was 7 over a, and we cross multiply. 4a times 7 equals 20 minus a times a. So 7 times 4 is 28, so I get 28a equals 20a minus a squared. Bring my 28a over to the other side, and I get 0 equals negative a squared minus 8a. All right, so the right-hand side looks factorable. Pull out a negative sign and an a, and I'm left with an a. If I divide negative 8a by negative a, I get plus 8. So it looks like I got two answers. It looks like either a is equal to 0 or a plus 8 is equal to 0, which means that a is negative 8. So doing it this way, look, that a equals negative 8 matches, but now I've got an a equals 0. Does it make sense for a to be 0? We'll go back to my original problem. If a is 0, I'm going to end up dividing by 0, so that doesn't work. So in the process of setting this up, we ended up with what we call an extraneous solution. Even though we got a equals 0 and we didn't do anything wrong, there's nothing mathematically incorrect about the process that we did. When we set it up and ended up with that extra value, that a equals 0, we went back and checked it, and a equals negative 8 will work fine. A equals 0 will not. All right, let's take a look at the first one up here. This one looks like it's easy enough to clear out those fractions because the 1 is over a 1. So we got a 1, an x, and an x squared. Let's multiply everything through by x squared to get rid of those denominators. So I'll multiply this term by x squared, I'll multiply this term by x squared, and that term by x squared. So I end up with an x squared plus x, right? An x squared on the top and x on the bottom. 1x knocks off top and bottom. And then if I have an x squared top and bottom here, I get a 12. Oh, now I got a quadratic to solve. X squared plus x minus 12 is equal to 0. This one looks factorable. Factors of negative 12 that differ by 1, I'll go with 4 and 3, with 4 being the bigger one. Check out my factoring and make sure it works. It does. One solution then is x equals negative 4. The other is x equals positive 3. Do they both work? Well, let's try x equals negative 4. We'll get 1 plus 1 over negative 4 equals 12 over, well, negative 4 squared is 16. And sure enough, 1 minus a quarter, 12 over 16 is 3/4. So 1 minus a quarter is 3/4. X equals negative 4 works. How about x equals positive 3? I get 1 plus 1 over 3. On the other side, I get 12 over 3 squared is 9. Again, 12 ninths is 4/3. On the other side, 1 plus 1/3 is 4/3. They both work. All right, the one under it you could try doing by cross multiplying. You'll end up with something similar to what we had up there, which is a quadratic. Let's take a look at the one on the top here. 2 over x plus 3 equals 5 plus 2 over x plus 3. Let's try getting rid of the x plus 3's. So I'm going to multiply every term top and bottom, well, I should say left and right, by x plus 3. So over here, the x plus 3's go away, and I get a 2. On the other side of the equal sign, 5 times x plus 3 is 5x plus 15. And here, those x plus 3's go away, and I just get 2. Right, so simplify a little bit, I get 5x plus 17. Get rid of a 17 from both sides, and I get negative 15 equals 5x. Divide both sides by 5, and x is negative 3. Think we're done, or maybe not. Go back to the original question. The original question had a whole bunch of x plus 3's in the denominator. So if I look at my solution, I got a negative 3 for x. Try putting that in here for x. Negative 3 plus 3 is equal to 0. That makes the fraction undefined, which means that even though we got a number, we got x equals negative 3, that's not a solution. Because if you put the answer back into the fraction and you get something that's undefined, then that means that's not a solution. So even though we got x equals negative 3, we find out it doesn't work, this problem has no solution. Now that I did this, go back to the original question, and you realize it was kind of a silly question to ask, wasn't it? It was something equals 5 plus the same thing, right? So it was like m equals 5 plus m. Well, unless m is equal to 0, that statement can never be true. And there's no way you're going to get 2 over x plus 3 to equal 0, so there's no solution to the problem. So I just wanted to do one that showed you that you can work your way through and get a solution, but that solution doesn't necessarily work. Go back and check your answer to make sure it makes sense. And in this case, even though we got x equals negative 3, when we substituted it back in, it didn't make any sense. All right, what do I do when I've got a problem like the first one up there? An x over 2x plus 2, I got a 4x plus 4, and I got an x plus 1. Am I really going to have to multiply both sides by 3 different binomials to clear out those fractions? Well, let's try a little factoring here. I got a 2x plus 2. Pull out a 2, and that's 2 times x plus 1. 4x plus 4, if I pull out a 4, is 4 times x plus 1, and that's plain old x plus 1. So it looks like really this will clear out all 3 fractions. The point being that if you can simplify the denominators, you might find a least common multiple that's a whole lot easier than multiplying all 3 of those all the way across. So if I multiply top and bottom by 4 times x plus 1, let's clear out a little space here. Multiply this by 4 times x plus 1, multiply this by 4 times x plus 1, and multiply that by 4 times x plus 1. Well, we already said that this was 2 times x plus 1. So here, the x plus 1's go away. 4 divided by 2 is 2. So all we're left with in the first term is the 2 and the x. Other side of the equal sign. 4x plus 4 up here cancels with the 4x plus 4 down there, and we're left with negative 2x. Over here, the x plus 1 here cancels the x plus 1 there, and now we just have to distribute the 4 to that 2x minus 3. So 4 times 2x is 8x. 4 times negative 3 is negative 12. And now this looks a whole lot nicer. 2x equals 6x minus 12. If I subtract the 6x from both sides, 2 minus 6 is negative 4. So negative 4x is negative 12. X is equal to 3. Okay. And I can go back in and put that 3 in and check that it works. In the beginning, I've got a 3 on the top. And then 2 times 3 is 6 plus 2 is 8. So left-hand side gives me a 3/8. Negative 2 times 3 is negative 6. 4 times 3 is 12 plus 4 is 16. And then a 2 times 3 is 6 minus 3 is 3. And 3 plus 1 is 4. All right. Actually, 6 over 16 simplifies to 3 over 8. 3 over 4 is 6 over 8. Yes. 6/8 minus 3/8 is 3/8. It works. Okay, so a quick check tells me x equals 3 is my solution. Oftentimes I can tell just by looking at the denominators, right? Putting in a 3 doesn't return a 0, so I think we're good. All right. The next one will make a short little video for solving for variables, and then we'll do a work problem as well.